So hi there, in this final video for this week for the 11s game, we go over how to remove two cards that add up to 11. So I have a method here called remove 11. In it, I first set a Boolean called found 11 to false because we haven't found an 11 yet. I have two utility integer variables just to store card values. Now the concept here is a nested loop. The outer loop will determine sort of the first card, and then the inner loop goes through all the other cards to the above that in the array, looking for one that combined with the current card, the two values equal 11. So let's look at these loops in detail. I have OL for outer loop equals 0. OL is as long as OL is less than cards.size minus 1. I'm doing the minus 1 because I'm doing a plus 1 down here because I want to start looking one above the current card, the card determined by outer loop. So that doing a plus 1 there means I have to do a minus 1 here to balance that. And I haven't found an 11. I just want to find one 11 here. If there's more than one, I'm not worried about it. I just want to find one, and then I'm done. And then I increment OL. Inside of that loop, I set card value 1 equal to the value of the card at the OL position. Then I have the inner loop, and that goes, as I noted, from OL plus 1, starting just above, the card just above the card determined out here. And that loop will go as long as cards.il is less than cards.size. It'll go all the way to the end. And not found equals 11. Again, as soon as I find an 11, I want this to end. Increment ILL. So inside this inner loop, I say card value equal to 2, equal to whatever the card value is at the IL position. Then I just check to see if those two card values are equal to 11. If they are, then found equals true. I remove the card at the IL position first. That's the higher index position, remember, because array lists, everything shuffles down automatically. So if I move the OL position first, then IL would no longer be where the card I need to remove is, because that would have shuffled down because of removing the card at the OL position. So be careful about this, right? You always have to be aware of the array list property that if you remove an element, everything above it in the array list shuffles down. So higher one first, then the lower one. Then I print out I removed an 11. And because of the setting found to true, both loops will be finished and this method will end. Okay? Now, just to finish up here, I needed to make some changes to the game, sort of the structure of the game, play game. So first I do this because I want to be able to play this multiple times easily. Every time I call play game, I'll remove any cards from the last game that are in the cards array list, basically the person's hand. So we start from scratch. I set J, Q, and K to false. These are the global Booleans. I say game over is false because I'm starting again. I shuffle the deck. And now, well, not game over. I use a while loop here to fill up the hand. The first time it will be 9 cards, but after that it will be either 3 or 2. I print the hand. If J, Q, and K are all true, then I remove J, Q, K, call remove J, Q, K. Else, I call remove 11, right? I'm either removing the Jack, Queen, and King set or a pair of 11s. That's all I do. Keep things very simple. Then I print the hand. And then I output how many cards are left in the deck, which is the deck.size. Then I say, how do I know if the game's over? Well, if I was unable to remove either an 11 or a Jack, Queen, King, the card size will be equal to 9. There'll still be 9 cards. So that means the game's over. Or card size equals 0, meaning that I was able to get rid of all the cards in the deck and in my hand. And in either of those cases, game over equals true. This is outside the loop, the while loop, this while loop, right here. So the while loop goes from there to there. When we exit the while loop, if card.size equals 0, then I know that the game ended because I won, so to speak. And otherwise, it will say nothing. Okay? So let's make a new 11s object, and we'll play a game. And we got down to 32 cards before it got stuck. 35. I found that it's about every 7 or 8 games that it will actually, there's a winnable game. Interesting to run some statistics on this. Set it up so it runs multiple times there. Got down to 0. Right? Final 2 cards removed were a 3 and an 8. So, at any rate, that's a working version of 11s. And you should get your own version working. You can use this video to help, obviously. Next week, we're going to look at some things related to generalizing 11s. So abstracting some of what we've done here so we could use it in other card games. Okay? Thanks. Have a great weekend.